Hi, welcome back to my channel. My name is Gina. In this video, we're going to talk about the sigma notation that I mentioned in my last video. A sigma notation is a language used to represent a sum of terms without having to list these terms. For example, the sum of A1, A2, A3 until AN can be expressed under the sigma notation form. The sigma is the summation symbol, and underneath there's a letter K, or it can be any other letter. K equals to any value. The K is the summation index, and the value is the first value of the summation index. And above the summation symbol, there's N, and that is the last value of the summation index. And on the right, there's A subscript K, and it is the terms of the sum. For example, sum of 2k plus 1, and it starts when k equals to 1 until 25. So when we expand this, we're going to start with k equals to 1. Then plus 2 times 2 plus 1 plus 2 times 3 plus 1, and it keeps going until when k equals to 25. So the last term is 2 times 25 plus 1. There are two summation rules. They are similar to the derivative and limit rules. The first one is constant multiple rule. It says if you have sum of a constant times a term of the sum, then you can put the constant c outside of the summation symbol. So it equals to c times sum of ak, and it starts when k equals to 1 until n. The second rule is the addition and subtraction rule. When you have the sum of a term plus or minus another term, you can expand this as sum of the first term, ak, it starts when k equals to 1 until n, plus or minus the sum of the second term, bk, and the index starts at 1 until n. There are 4 summation formulas. I recommend you to just memorize them because later on in Calculus 2, we'll use them a lot to calculate the sign area. The first formula is when you have 1 plus 1 plus 1, and in total you have n terms. In sigma notation, you write it as the sum of 1, and the index starts at 1 until n. And this simply equals to n. The second formula, when you have 1 plus 2 plus 3, and it keeps going until you have plus n. In sigma notation, it's the sum of k, when k starts from 1 until n. And this equals to n times n plus 1 over 2. Then the third formula, when you have 1 plus 2 squared plus 3 squared, until when you get to plus n squared. In sigma notation, it's sum of k squared when k starts from 1 until n. And this equals to n times n plus 1 times 2n plus 1 over 6. Then the last formula, when you have 1 plus 2 cubed plus 3 cubed until when you get to plus n cubed. In sigma notation, it's sum of k cubed, and it starts when the index is 1 until n. And it equals to n squared times n plus 1 squared over 4. Now let's look at an example. Sum of 5k squared plus k minus 2k cubed, and the index starts from 1 until 30. We can use the second rule of summation to expand this as sum of 5k squared from k equals to 1 to 30 plus sum of k when k equals to 1 until 30 minus sum of 2k cubed when the index starts from 1 to 30. Then we can use the first rule to pull the constant outside of the sigma notation. So the first term is 5 times the sum of k squared starting from 1 to 30. The second term remains the same, sum of k from 1 to 30. Minus, here we pull the 2 outside of the sigma, so we get 2 times sum of k cubed starting from 1 to 30. Then we can use the summation formulas to substitute this, and this. So this equals to 5 times sum of k squared, and the formula for that is n, which is 30, times n plus 1 times 2n plus 1 over 6 plus sum of k, and the formula for that is n times n plus 1 over 2, and n in this case is 30. So 30 times 31 over 2. And the last term, minus 2 times sum of k cubed, and the formula for that is n squared, which is 30 squared, times n plus 1 squared, 31 squared, over 4. Now let's simplify the equation. And you get negative 384710. That is the end of the video. I have a course on this section of Calculus 2 on Udemy, and it's free to enroll. I'll put the link down below. At the end of the course, you'll also get an assignment with solutions for you to do some hands-on practice. If you like my videos, please subscribe to my channel and give me a thumb up. And I'll see you in the next video.